Hey guys, welcome to Studying Eye. Did you know that the chances of fertilized egg implanting into the uterus is only about 25%? That's right. Only 1 in the 4 embryos successfully implant, making it a very crucial step in the journey to parenthood. But what exactly happens during implantation? How does this tiny embryo attach itself to the uterine wall and start growing into a baby? Come on, let's dive in and explore the fascinating process of implantation. What exactly is implantation though? Implantation is nothing but when a fertilized egg or an embryo attaches itself to the lining of the uterus, or you call it uterine wall, and it starts growing to develop into a fetus or a baby. This process generally starts around day 7. So what happens is trophoblast binds to the uterine wall with L-selectins and integrin receptors and penetrate between the epithelial cells. Here, as you can see, this is your blastocyst, this is your trophoblast, and this is your embryoblast, also called inner mast cell and outer mast cell. What happens is, you can see here this junction where there is a lock and key mechanism. These are nothing but L-selectins and integrins. And the presence of these two facilitates your implantation. So, uterus at implantation is in its secretory phase, where it is secreting various things, right? So, what happens here? There is high level of progesterone in secretory phase, which is released from corpus luteum, which is very essential for your implantation in the endometrium. Since the uterus is in the secretory phase, there is increased level of progesterone which acts on the uterus, and there is proliferation of the uterus taking place here. The trophoblast that we saw earlier divides into two parts. One, cytotrophoblast, and second is the syncytial trophoblast. This blastocyst gets implanted into the decidua basalis in the posterior wall of the uterus. It is a very important MCQ. So, let's study about trophoblast in detail. Your trophoblast proliferates into two layers. One is the cytotrophoblast and the second is syncytiotrophoblast. So, as you can see, cytotrophoblast is nothing but cellular trophoblast that forms the placenta. It is the inner layer of the trophoblast and it contains mononucleated cells, which means it has only single nuclei. What are its functions? It functions as it produces the primary chorionic villi. Villi are nothing but the finger-like projections, and it protrudes into the syncytiotrophoblast. The second layer of the trophoblast is syncytiotrophoblast, which is also the outer layer of the trophoblast, and it is multinucleated cells. Means a single cell will have multiple nuclei. It functions as it invades the decidua basalis layer. So, it actually crunches in, moves in and erodes the decidua basalis layer of the uterus. It makes certain enzymes that erode this uterine wall. Human chorionic gonadotrophin, also known as HCG. This HCG maintains the viability of corpus luteum. What was corpus luteum doing? It was increasing progesterone, right? Now what happens here? It secretes progesterone and estrogen until 8 weeks of pregnancy. So, till 8 weeks of pregnancy, the HCG in the body maintains the level of both these hormones, estrogen and progesterone, so that your pregnancy is maintained. Now, there's a question for you guys. Tell me, what is the use of HCG in diagnosis or its importance in pregnancy other than this, what we are studying here? Since we are done with studying about the trophoblast, let's go ahead and understand what embryoblast does. So, your embryoblast also divides into two layers. One is the hypoblast and the second is your epiblast. Both of these form flat disc-like structures. So, the hypoblast is small cuboidal cells. So, it contains small cuboidal cells like you can see here, and it is present adjacent to the blastocyst. This hypoblast actually lines the yolk sac of the embryo. Further, the epiblast layer of the embryoblast is having columnar cells in it. It's present in the dorsum of the embryo and it forms the germ layers. This epiblast forms a cavity. This cavity is nothing but the amniotic cavity, and since it forms amniotic cavity, your amniotic cavity is lined by amnoblast cells, which is also a part of epiblast. Since we're already done with day 7 and day 8 activities, let's go ahead and study about the day 9 activities. What exactly happens on day 9? So, the lacunar stage of trophoblast development happens in the day 9. What happens is, there is appearance of vacuoles in the syncytium. And these vacuoles come together and fuse. And this fusion forms a larger cavity or also a larger space. And this larger space is known as lacunae. So, at the embryonic pole. Okay, let's clear the term. What is embryonic pole? We have your blastocyst. So, this part contains your inner mass cell. The inner mass cell area is known as the embryonic pole. So, from this part, your future embryo will grow. The part exactly opposite to it is known as embryonic pole. Got it? So, at embryonic pole, the cells flatten and they form exocoelomic membrane. Now, this exocoelomic membrane is also known as Husser's membrane. This exocoelomic membrane lines the inner surface of the cytotrophoblast. And this activity takes some time and it happens from 9 to day 10. Moving further, approximately around the day 12, we have the progesterone level continue to rise. As the uterus is in its secretory phase, the progesterone levels will be rising. And your decidua basalis, also the decidua, undergoes decidual reaction, which is a decisive reaction. Now, this decisive reaction means it's like a reaction where a switch will flip. So this part determines what path will the cell take. This reaction is usually triggered at specific signals such as due to chemicals or physical cues. During the embryonic development, the cells face the crossroad, the decisive point where they decide what will they become. Will they become a nerve cell, a muscle cell, or a skin cell? Okay? So, the decidual cells enlarge in size and get coated by sugar-rich fluid. And this sugar-rich fluid is very important for sustaining the embryo. Again, as we earlier studied about the lacunae, now what it happens is, the lacunae will fuse with the sinusoids. And these sinusoids get filled with the maternal blood. Once they are filled with the maternal blood, there's something called uteroplacental circulation takes place. Now, this ensures that the uterus provides the blood to the placenta and the blood goes to the fetus. And this is known as uteroplacental circulation. Around day 13 or so, the secondary yolk sac formation takes place in the exocoelomic cavity. The hypoblast cells get converted into the extraembryonic mesoderm, which is present outside the embryo, and your epiplast is ready to form the 3 germ layers of the embryo, that is ectoderm, mesoderm and endoderm. A huge thanks for joining me into this journey of amazing world of embryonic development. I hope you had a blast, or should I say blastocyst, and learning about implantation. Now it's your turn to help me grow. Please do like the video, share it with your friends and subscribe to my channel. Write the answer to the question asked in this video in the comment box. For proper understanding, please go through the previous videos in the playlist of embryology on my channel. Thanks again for watching. Until then, have fun studying. Ta-das!